Hello friends, let's look at this problem today. So I'm going to skip reading the problems. I think you can read yourself. Basically what we want to do here is to calculate the lowest impact value. I think there are 4 nucleotides in a DNA sequence. They are A, C, G, T, and they have corresponding impact factors 1, 2, 3, and 4. So nucleotide A has impact factor 1, C has impact factor 2, and G3 and T4 respectively. So given a DNA sequence, for example, we have S as a DNA sequence and also a interval defined from 2 arrays P and Q. P is starting position of the nucleotide in the DNA sequence, and the Q is the stop position or stop nucleotide of the given DNA sequence, and we want to calculate the smallest impact value. Here's example. For example, for the positions between 2 and 4. Okay, so 0, 1, 2. So 2, 3, 4. There are two possible nucleotides, G and C. And between G and C, G has impact factor 3 and C has impact factor 2. So we want to return 2 because 2 is a smaller impact factor. Okay. We're going to use prefix sum for that. Very simple, because we only have 4 nucleotides. What we will do is to calculate prefix sum for all 4 nucleotides. Okay. We will first define a result. I think the size of the result is going to be the same as the size of P and Q. And the result is going to be what we return. And next we are going to define the prefix. I say this is a prefix for nucleotide A. We're going to use the length. We're going to define 1 for each of them. Okay. We will have a prefix sum for C, prefix sum for G, and also prefix sum for the nucleotide T. Okay, and then we're going to calculate for all of them. So we're going to have a count. We use this count to count the occurrence of nucleotide A in sequence S. Initialize this to 0. We will have to define 4 of those for each nucleotide. So we'll have count C, counting the occurrence of nucleotide C in the DNA sequence S, and the G. Finally, this is for counting nucleotide T. Next, we're going to calculate the prefix sum. So what we can do is to loop through the string s. So I equal to 0 and I is less than s length. And I increase by 1. So for each one, we want to capture the chart. So we call it n, short for nuclear tag. We're just going to call it nuclei. Make it more clear. So this would be an uppercase letter A, C, G, T. It's a char at. So at the S position, we get the nuclear tag. Here, we want to see if nuclear tag equals to A or not. If it equals to A, then we want increase count A by 1. And also we're gonna update the prefix at the corresponding position. Well, we have to update that after we done everything. Okay, so so this is for nuclear tag A. We're gonna have to also calculate for nuclear tag C and G and also T. And to change that to C, so C will be increased if the letter is C, and if the letter is G, count G will be increased, and if the nuclear tag is T, then count T will be increased. Okay. After that, we will have to update the prefix. So the prefix I will equals to count A. Again, we do that for each nuclear tag. So this is prefix C. We assign count C to this, and we assign prefix G to count G. Sorry. We assign prefix T to count T. Okay. So after that, we will have all the prefix for each nuclear tag calculated, and then we can just use the prefix to determine whether a nuclear tag or type of nuclear tag exists in a certain interval or not. So for example here, from 2 to 4, 0, 1, 2, from 2 to 4, all we need is to calculate the occurrence. So for example, G at this position would be 1. At this position would also be 1 here, and then 1 minus this would be just 1. So that would indicate that there is occurrence G inside this interval. The similar thing goes to C here. We just see the occurrence. So at this position, occurrence of C would be 1, and here would be 2, and here would be 3. So 3 minus, here would be 1, 3 minus 1 would be 2, so that indicates that there's also nucleotide C existing in this interval. From there, we just pick the nucleotide with the smallest one, smallest impact factor. That's all. Okay, so next let's loop. We're going to loop from the P and the Q. Int I equal to 0 and I less than P dot length, and I increase by 1, and so start position would be P of I, and the position would be Q of I. Yeah. All right. So we will start from the smallest, the nucleotide with the smallest impact factor, which is A. So let's say if so how do we calculate? So if starting position is 0, okay, let's just do them one by one. Okay. So first we're going to calculate for nucleotide A. Okay. So start occur. So that depends on the start position. If start position equals to 0, then the occurrence should be just 0. Okay. Otherwise, the occurrence should be prefix A start position minus 1. Okay. And occur would be just prefix A and the position. Yeah. So if and occur minus start occur is greater than 0, then this letter must have occurred in that interval. In which case we want to assign result of position I to the corresponding value, which is 1. Okay. So this is for A. We got to do the same thing for other nucleotides. Okay, we'll fix the errors later. Okay, so this will be for C. This will be for G. And this will be for T. Okay. Okay, so we just have to change to the corresponding value. So here we want to look at the prefix C. So again, this is the prefix C. And here we want continue. So this impact factor is 2 for C. We'll continue. We probably okay. Won't continue from here, yeah. Just change this. This would be for prefix T. For G. Again, this is the prefix G. Star and occur. The corresponding impact factor is 3 for G. Yeah. And we want to continue. We want to skip all of the statements after that point. For T, we're looking at prefix T, and its impact factor is 4, and we don't have to continue because it's end of the loop. After that, we should have the result. Okay. So let's run the code. Compilation successful. Okay, so it passed the example test. What's the time complexity? Let's see. We created 4 arrays of size number of characters S. So this is the size of the array is the number of nucleotides. We have a for loop looping through the nucleotides in the DNA sequence S exactly once here. And then we have another for loop looking through all the positions and also exactly once. So the time complexity T of n would equals to big O of max of m and n, and here we assume m is the length of S and n is length of P or Q. The space complexity would be just big O. Would be the same, but we can also say that that is 4 times that. Well, it's not the same. Sorry, it's 4 times I guess m, 4 times m. Okay, let's submit. Being evaluated. Hopefully no problem. I did spend 21 minutes to finish the whole thing. Well, that's it. Again, thanks for watching, and I hope you all have a nice day. Bye bye.